You are listening to The Vocal Technologist. Spoken tech for your ears.
So the bit rattling around my head is this. The first audience for your work isn't even human anymore. It's a machine.
Yeah, it is a profound shift. We are basically performing for the algorithm first and then the person second.
Exactly. And honestly, it's why I love that we get together to do this whole vocal technologist thing, just batting these ideas around. Because for you listening right now, we really need to untangle this massive collision happening at the moment. You've got AI generating endless output on one side, corporate trust completely fracturing on the other, and caught right in the middle is, well, the enduring value of actual human craft.
The tension there is palpable, isn't it? Because you can't design a product for an AI proxy if you don't first understand how that same AI is breaking our foundational trust in digital reality.
Right, which brings us to the part nobody's really talking about with satellite imagery. We've always treated a photo from space as the ultimate objective truth.
Oh, absolutely. The eye in the sky.
Yeah, it's the one thing you can't fake. Or so we thought. But Google Earth rolled out this nano-banana image generation feature, and they had to pull it down almost immediately. The initial idea was completely benign. You could, generate AI images grounded in real 3D maps.
Right. The idea was you could visualize a new patio on your house or maybe build a nice educational infographic about urban sprawl.
Exactly. But it went sideways fast.
What's fascinating here is how quickly the open source community and journalists sussed out the system's vulnerabilities. Within hours, people were generating incredibly convincing, completely fake imagery of disasters.
Oh, wow.
Yeah, we're talking about fabricated flooding at the U.S. Capitol or fake fires raging on Iran's Karg Island, which is a major oil terminal.
Which is incredibly dodgy when you consider how tense things get geopolitically. People were already circulating fake satellite images during the U.S.-Israel-Iran conflicts. If you can't trust a satellite image to verify if a military base is intact, what can you trust?
Precisely. And, Google did try to build safeguards. They used their synthide watermark. Now, in isolated lab testing, synthide is incredibly robust. It embeds a pattern into the pixels that is totally invisible to the human eye.
Right.
It actually survived 300 rounds of aggressive compression and resizing, but it has a fatal flaw: cropping.
Wait, cropping? How does just cropping an image defeat an advanced AI watermark?
Because the watermark relies on the mathematical distribution of noise across the entire image canvas. So if you crop the image heavily, say just zooming in on the fake fire on a single building, and then compress it, you destroy the structural integrity of that hidden pixel pattern.
Ah, I see.
The detection algorithm simply can't read the fragmented data anymore.
Mate, that is a bit ordinary. It's like trying to catch rain with a tennis racket.
That's a great way to put it.
You can put all the invisible watermarks you want on an image, but the data is already out there in the wild, and bad actors know exactly how to strip it out just by taking a zoomed-in screenshot.
And that is exactly why security experts are arguing we need to completely abandon watermarking as our primary defense. It's a losing battle. The better long-term strategy is cryptographic metadata, specifically the C2PA standard.
Okay, break that down for me a bit. How is C2PA different from just, another watermark?
Well, instead of trying to flag every single piece of fake synthetic media, which is statistically impossible given the sheer volume AI generates, you authenticate the genuine content at the source.
Right.
C2PA establishes a digital chain of custody from the literal moment the camera sensor captures the light. The camera's hardware signs the image data with a cryptographic hash.
So it's not a sticker placed on top of the image. It's basically a mathematical seal baked into the file's DNA by the physical hardware itself.
Exactly. So if anyone alters the pixels in Photoshop or uses an AI to generate a similar image, that hardware-level cryptographic seal just breaks.
So you don't even have to prove the image is fake.
No, you just have to notice that the signature of authenticity is missing or invalid.
That makes heaps of sense. But the fake's outputs are only half the problem here, really. Look at the inputs, the actual data these models are trained on. It is getting heavily litigious. Apple is currently seeking a preliminary injunction against OpenAI over allegedly stolen hardware trade secrets.
Yes, and Apple's core claim there is that they are suffering irreparable harm because OpenAI is allegedly using that confidential engineering information to accelerate their own hardware development.
Right.
OpenAI agreed to preserve evidence and stop using the disputed files, but they flat out refused Apple's requests for forensic inspections of their systems.
Which feels a bit sus, doesn't it? Refusing a forensic search while publicly rejecting the allegations. It's basically saying, trust us, we aren't using your blueprints, but no, you cannot look in our filing cabinet.
Yeah, it's a standoff. And it's not just the big tech players fighting each other either. Artists and writers are suing the AI companies too. We saw that massive $1.5 billion settlement in the Bart's v. Anthropic case over pirated books.
Right, but there's a lot of nuance there, isn't there?
There is. It is worth noting the strict legal nuance in that case. The judge actually ruled that training an AI on legally acquired scanned books counts as fair use because the AI is extracting statistical patterns, not reproducing the text verbatim.
Oh, okay.
The settlement was massive, likely just to avoid a prolonged jury trial, but the legal precedent still leaves creators entirely wondering how they are going to protect their livelihoods long term.
Right, so we are desperately trying to legally ring-fence what data goes into these models and cryptographically lock down the images that come out. But what about the software that sits right in the middle? Because the way we actually build that software is being entirely warped to suit the machine. Like, if the AI is the first audience, how do we actually design for it?
Well, we have to completely rethink Jacob's Law.
Oh, the old UX rule.
Yeah. Historically, in user experience, Jacob's Law states that users spend most of their time on other websites, so they expect your site to work like all the others. Familiarity wins. Visual consistency wins.
Makes sense.
But now, users are increasingly spending their time in conversational interfaces AI assistants, like ChatGPT, Claude, or Copilot.
So the assistant is the new UI. I'm not browsing a store. I'm just asking an agent to browse the store for me and buy the shoes.
Precisely. Products now need to be optimized for these AI proxies. We are seeing a huge push towards standard protocols like MCP, the Model Context Protocol, and A2UI, which stands for Agent to UI.
Wait, so instead of building a beautiful graphical checkout button, what are we actually building for the agent? Just code.
You're building machine-readable structure. Instead of relying on a visual CSS grid that looks nice to human eyes, your site feeds raw, structured JSON data directly to the AI agent.
Oh, I see.
The agent needs to read the checkout endpoints function, understand the pricing parameters, and execute the action without ever seeing a graphical interface. Before a human ever visually processes your product, the AI has to be able to navigate it, understand its logic, and summarize it.
Which is giving rise to this entirely new breed of worker, the creative technologist. It's people who are treating code not as a rigid engineering discipline where you memorize syntax, but as a fluid creative medium.
It really is a fascinating workflow shift.
Yeah, they're using tools like Cursor, an AI code editor, to essentially art direct AI agents. I saw a case study where a designer was building these highly complex interactive gear graphic animations. Normally, that takes deep math and rendering knowledge.
Right, lots of specific expertise.
But they were just refining the shapes and the motion loops by chatting with the AI. Like, make it spin a bit slower, add a shadow here, connect the teeth of the gears. They aren't writing a single line of JavaScript. They're directing the vibe coding.
And enterprise is taking vibe coding very seriously. It's not just for indie developers tinkering around. AWS just backed a startup called Superblocks, signing a massive multi-year deal to embed their tool inside private corporate clouds.
Oh, really?
Yeah, it allows companies to build internal apps using these AI orchestrations, but keeps all their proprietary data locked down entirely behind strict IT security controls.
But integrating AI into existing design tools is so messy. Look at Figma. They finally rolled out nested folders, which, I mean, sounds like the most boring update ever. I reckon my old Windows 95 machine had nested folders.
It does sound basic, yeah.
But to make that one simple feature work, Figma had to completely rebuild their content and permission systems from scratch. It totally blurred the lines between their design and engineering teams.
It was a massive architectural overhaul, and they had to do it because they are pushing further into AI with Figma Make, introducing an AI properties panel and annotations. You can adjust typography and spacing visually, or use in-context prompts to tell the agent to add a specific hover effect. But here is the critical issue with all this AI generation. AI drifting.
Hang on. How does code actually drift from a design? Is the AI just slowly hallucinating a different shade of blue or adding random pixels every time it touches the file?
Basically, yes. AI drifting happens when your design components and your actual front-end code slowly fall out of sync over multiple iterations. Because LLMs are probabilistic, an ungoverned AI might generate slightly different padding or a slightly different hex code for a shadowed each time it updates a component.
Wow.
So over weeks, the code drifts away from the original design system.
That sounds like an absolute nightmare for quality control.
It is. The solution emerging is called component contracts. These are highly specific, plain language specifications that serve as a rigid source of truth.
So instead of just telling the AI, build a primary button, you write a contract that says a primary button must always use this exact hex code, have a 4-pixel border radius, and never exceed 48 pixels in height.
Exactly. When you pair those plain English contracts with what is called harness engineering, which is basically building deterministic, hard-coded guardrails that the model absolutely cannot override, the results are staggering.
Really? How so?
Well, in one recent test, an ungoverned AI agent scored 69 out of 100 on accurately building user interfaces. When governed by a strict component contract, it scored a perfect 100 out of 100.
A perfect score just by giving it clear, plain English boundaries. That is incredible. Hey, tap subscribe or check on notifications on whatever app you're using right now so we can keep untangling this stuff together. There's heaps more to get through.
It really is a great point about boundaries because it introduces a fascinating tension. If an AI can generate perfectly coded interfaces from a text prompt and churn out endless variations of product ideas, why are 95% of corporate AI projects totally failing to launch?
Yeah, that stat is wild, 95%. If the tech is getting perfect scores in lab environments, what is breaking down in the real world?
The bureaucracy trap. We have this pervasive misconception in corporate culture that a lack of ideas is the primary bottleneck to innovation. It's not. Ideas are incredibly cheap, and AI makes them cheaper. True invention is actually about killing weak ideas quickly.
Right.
The real blocker in these corporations isn't the technology at all. It's organizational debt.
Which means what exactly?
Yeah.
Endless meetings.
Excessive layers of approval, fragmented departments, and a fundamental lack of trust in their employees. If an AI can generate an app in an hour, but it takes 6 months of committee reviews to approve the deployment, the AI hasn't solved anything.
It's like buying a Ferrari to commute in bumper-to-bumper traffic.
Spot on.
The engine doesn't matter if the road is blocked. So AI fluency isn't the finish line.
Not at all. Human facilitation is. The companies winning right now are the ones empowering small, cross-functional teams to openly experiment, make fast decisions, and share their failures without fear of corporate reprimand.
I have a bit of a confession, actually, speaking of the human side of this. I've been experiencing some serious AI fatigue lately. I was trying to vibe code a personal project a few weeks back, and I just got totally burnt out on the endless prompting. The tweaking, telling it to fix a tiny bug, it breaking something else.
It gets exhausting.
It really does. It made me realize I genuinely missed just getting my hands dirty and making things myself, flaws and all.
That fatigue is a recognized phenomenon, and it ties directly into a psychological concept called hedonic adaptation.
I know this one. It's like noise cancellation on your headphones. The first day you turn it on a crowded train, it feels like pure magic. A week later, it's completely invisible to you.
Exactly.
You only ever notice it again when the battery dies and you are furious about the background noise.
That is a brilliant way to look at it. Hedonic adaptation dictates that humans rapidly adjust to positive changes, returning to a baseline level of happiness. In software development, this means user satisfaction on an entirely unchanged product slips roughly 2 to 5% every single year.
Just because their baseline expectations rise.
Precisely. But here is the trap. Companies try to fight this fading satisfaction by endlessly chasing novelty. They add gamification, new AI features, radical visual redesigns.
But delight is fleeting.
Yes. Do you know what doesn't fade? Irritation. A recurring annoyance will frustrate a user forever. Instead of chasing novelty, product teams should relentlessly fix annoyances.
Oh, there's a brilliant case study on exactly this. A design team was tasked with overhauling their software's pricing page because conversions were dropping. Instead of asking an AI to generate a sleek new layout or running an A/B test on button colors, they just sat down and analyzed over 200 customer complaints from their support tickets.
And what did the complaints reveal?
They realized people weren't mad about the cost at all. They were just completely confused by the mental models of the plan names and the feature lists. The language was opaque.
Interesting.
So they treated those human complaints as elite user research. They completely rewrote the page to answer those specific confusions, didn't change the actual prices, and massively improved the conversion rate.
It proves that the most valuable user experience insights aren't coming from an AI analysis of broad market trends. They come directly from human friction and frustration.
Which perfectly explains this massive counter-trend we are seeing across the design world. Brands are aggressively returning to physical, nostalgic, highly human-centric design just to stand out from the slick, frictionless AI homogeneity. Like, look at typography. Good old-school type design has all these hidden human details like optical sizing or ink traps.
Ink traps are a perfect example of human constraint driving aesthetic beauty. They were originally designed as deep cuts in the corners of letters so that wet ink wouldn't pool and blur when printed on cheap, porous newspaper.
Oh, I didn't know that.
Yeah, but now they're often used as an aesthetic choice in high-end digital fonts to add character, aggression, and warmth. It is a deliberate nod to physical craft.
And you see this embrace of imperfection everywhere right now. Vermont tourism just dropped their new state branding. People initially lost their minds online and accused them of using Comic Sans, which is hilarious.
Yeah, the internet reaction was wild.
But if you look closer, it's actually a beautiful custom word mark inspired by Vermont's folklore, their rugged landscapes, and their history of hand-painted wooden signs. It's deliberately imperfect. Or look at Bethesda, the gaming studio.
Oh, the 40th anniversary branding.
Yeah. For their 40th anniversary, they completely ditched their clean, minimalist corporate logo and went straight back to their retro-futuristic 80s and 90s branding. The angular, chunky, cyberpunk typography. The fans absolutely loved it.
It gives a brand a soul, a sense of place and history. Gunnersbury Museum in London just did this brilliantly as well. They had this distinct problem where everyone locally knew the surrounding park, but nobody knew the actual museum existed inside it.
Right, so how do they fix it?
They built a modular, highly physical identity system, a green tree symbol for the park, a purple building symbol for the museum, and when they physically overlap in the signage and the branding, they create a bright yellow identity. It's a clever, tangible, wayfinding-driven approach that feels grounded in the physical world.
Even luxury retail is leaning heavily into the physical. Indus Eyewear just rebranded, and they didn't use some sterile AI-generated sleekness. They based the flowing asymmetrical curves of their new logo directly on the curve of a physical Daced sofa that sits inside their actual shop floor.
That's amazing.
It makes the digital brand feel like a direct extension of the intimate physical space.
Which is exactly why top design agencies like Kodo are doubling down on acquiring physical studio space. While tech companies push for remote work and AI-driven efficiency, Kodo argues that spontaneous in-person collaboration creates a creative culture and a standard of idiosyncratic craftsmanship that an AI simply cannot replicate. The friction of the physical environment literally shapes the output.
And to power all this weird blend of high-end, messy human craft and heavy-lifting AI generation, the physical hardware tools we use are getting a massive upgrade. The leaks right now are wild. Have you seen the Lenovo GoogleBook 15 leak?
I have. It's a very clear signal of Google's evolving hardware strategy. It is a premium laptop running an Android desktop UI, completely aimed at taking on high-end Windows laptops. And of course, it features a dedicated physical hardware key for Gemini, their AI assistant.
The hardware is physically changing to accommodate the AI proxy we talked about earlier. And Apple clearly isn't sitting still either. The Mac Studio refresh is looking like an absolute beast.
They're skipping the M4 Ultra entirely and moving straight to the M5 Max and M5 Ultra. We are looking at desktop machines with up to 768 gigabytes of unified memory. And looking ahead to the next architectural leap, the M7 chip is rumored to support up to 1.5 terabytes of unified memory.
Hold on, 1.5 terabytes of RAM. That is absurd. Even if you're rendering 8K 3D video, you do not need 1.5 terabytes of active memory. What is the point of that much overhead?
It sounds absurd until you realize exactly what it's engineered for. That memory ceiling isn't for running Photoshop or video editing, it's for running massive frontier-level AI models locally on your own machine. Large language models are heavily memory bandwidth bound.
Meaning what? It's not about how fast the processor is.
Exactly. It's not about computational speed, it's about how fast you can load billions of parameters into active memory. Traditional PCs split memory between the CPU and the graphics card, creating a massive bottleneck when moving data back and forth. Apple's unified memory architecture pools it all together.
Oh, right.
1.5 terabytes allows a creative professional to load an unimaginably massive multimodal AI entirely into active RAM, ensuring total data privacy and zero latency.
That makes total sense. You aren't pinging a server farm in another country. The brain is sitting right on your desk. We're also seeing physical design changes on the mobile front to change how we interact with these models. The Pixel 11 Pro Fold leaks show this new feature called Highlight. It's a glowy LED array that replaces the traditional camera flash on the back of the phone.
What is the primary use case for that?
It's designed for glance-free notifications. So your phone is face down at dinner, it pulses specific colors for favorite contacts, or glows gently when Gemini is processing a complex task in the background. It's ambient computing.
It's an attempt to keep you connected to the AI without demanding your full addictive screen attention.
Exactly.
But ironically, while hardware pushes AI integration, Apple's software is suddenly pushing in the exact opposite direction. In iOS 27, they're introducing a completely new captured by me camera roll.
Yes, I saw this and it blew my mind. It uses the device metadata to strip out all the screenshots, all the saved memes from group chats, all the AI-generated images you downloaded. It just shows you the true, organic photography that you actually took with your phone's physical camera lens.
It is a sanctuary for human perspective.
It really is, and I think that brings this whole conversation full circle. We are living in a world where Apple feels compelled to build a specific, dedicated folder just to prove that you, a messy human being, actually took a photo of a real moment. We are fundamentally craving that authenticity.
If we connect this to the bigger picture, it becomes remarkably clear that frictionless design is ultimately forgettable design. When an AI removes all the effort, it also removes the emotional resonance, the friction of human judgment, the physical craft of an ink trap, the imperfections of a hand-painted sign. That is what brings meaning and connection back to the things we build.
It makes you wonder, if verifiable physical reality and human imperfection become the ultimate premium luxuries, do we eventually just abandon the digital world entirely, leaving it as a sterile wasteland of bots endlessly talking to bots? It's something to chew on next time a tool offers to smooth out all your edges. Trust your own messy taste a little bit more. Vocal Technologists, see you soon.
Spoken Tech for your ears.